Good morning, students. So we will now demonstrate the milling operation through the milling machine. So milling is another machining operation through which different operation can be done, like your facing, and also you can see slot cutting is a very good example of the milling machine, also gear cutting. So there are different examples of the milling machine. Now we will go by one. Before going to milling machine, we should first see the milling cutter. So this is the milling cutter, as you can see. So you can see here these are the cutting edges. So there are multiple cutting edges which is associated with the milling cutter. So we are calling this particular milling cutter as your multi-point tooling or multi-point cutting tool. So we have seen the single point cutting tool in case of your turning, but for milling it is a kind of a multi-point cutting tool. As you can see that there are multiple cutting edges which are associated with the milling operation. Now when this particular wheel is rotated, you can now assume that when this wheel will be connected to some shaft and it will be rotated. So this cutting operation will be done continuously through each and every cutting edge. So this is the consist of several single point cutting edges which is ultimately giving you the multi-point cutting edges through your through your milling operation. So one of the useful example of the milling operation is the slot cutting operation. As you can see here, number of slotted. So you will see that some workpiece, suppose this is one workpiece, and these are the slots which has been cut on the particular workpiece. These are the parallel slots you can see here. So this has been cut. So you can assume now, just hold this particular job in the job catcher or job holder, then just operate this particular milling cutter like this way. Okay, and then move the workpiece in this direction. So here primary cutting motion we are giving to this particularly tool or your cutting tool, and secondary cutting motion feed we are giving through this particular workpiece, so that the material is being removed and this kind of a straight slot can be cut on this particular diameter or the particular operation. So this milling is useful for straight cutting or making some straight slot. Second operation is your helical milling. Means with helical milling we can cut slots with different angle. You can see that different angle slots has been cut. I can show you the example. So this is the example of the helical milling, or the slots has been created through helical milling. We can see that slots are not straight here, it is at a particular some angles. So these are the cutting slots with different angles, that is the helical milling or helical milling slot. So for that, what you need to do, you need to that angle is 18 degree, total angle is 18 degree. For that, one gearing arrangement has been done with two different gear teeth, which will, when we will see the machine, we will discuss about it. The two different gear teeth or gears with different teeth of 1:7:40 has been used, so that the gearing ratio which can help to rotate this workpiece with a particular 18 degree, so that the slotting operation can be done or the helical slotting operation can be done. So this is the two straight cut operation of the milling machine. Another operation which is many useful for the milling operation is the gear cutting. You can see here on my hand, it is a spar gear which has the particular profile of the gearing. So this particular spar gear have 44 teeth. If you see, each are called as a teeth, and you know this gear is very much useful, especially at the automobile while we are wanting to change gear. So this gear is helpful for any manufacturing devices. So you can see here, particularly in this spar gear cutting, we see that description of the job is mentioned here, like number of teeth is 44, diameter of the job is 97.5. So we are cutting this particular gear with the help of direct indexing or plane indexing method, where the number of times it should be rotated is given by 40/n, where n is the number of teeth. So it should be ratio is something like 10/11, which you can see here. So for a 30 mm, so you can use it like that, this ratio should be maintained. So now there is different plates on the indexing plate, which we will see when we will discuss at that particular machine. In that indexing plate, there are certain holes. So if a plate consists of 33 holes, so we should go for a cutting while cutting the gear up to 30 holes, so that we can cut the gear with that particular teeth or particular teeth dimension. So this is the particular cutter or the gear cutting tool which can be seen. It is also a milling cutter which is helpful for gear cutting operation, and while we are discussing in the machine, so we can see that how this particular cutting tool are being fixed and where the machine is or where the job is being fixed. Okay, so let us now go to the machine and we will show in the machine how this arrangement has been done on the machine. Okay students, now this is the milling machine by which we will do this milling cutter or milling operation, which is first operation is slot cutting. Before doing that, just tell about this machine. So this is the radial arm through which your on the spindle or on the arbor your main this cutting tool has been fixed here. You can see inside the cutting tool has been fixed here inside. So the main or the primary cutting motion will be given through this milling cutter. So this is the milling cutter which has been fixed, and this is the job through on which your slot is being cut, and in this job is hold through this particular transverse slide, and will give the feed mechanism or the feeding or the secondary cutting motion by this feed by rotating this particular slide in this horizontal direction. So this is giving for the horizontal feed for this particular machine, and these are the different fixture or these are the bed or the milling bed on which the while cutting that chip will be accumulated, and this is also giving this particular mechanism is giving the vertical feed to that particular machine. So these are the salient features of this milling machine. Now we will see the slot cutting operation, where the primary cutting motion will be given to that particular cutting tool and secondary cutting motion will be given this particular on the workpiece. And here the depth of cut is basically given through this particular system, that is with the you can see that particularly if we increase the height of this particular bed, then we can give the depth of cut. So that has been given through this, and in this particular process 3 mm we have given as the depth of cut to have that particular straight slot on the workpiece. So this is the slot which has been cut through this particular, you can see the slot. This straight slot has been cut through this milling operation, with this feed has been given through this workpiece. Primary cutting motion has been given through this particular cutting tool, and depth of cut has been given to particular this arrangement, so that the table can be up by a certain depth of cut amount, that is the 3 mm in this particular thing. Now we will see the helical cutting operation. Okay, so this is the second milling operation, that is the slot cutting operation, but in a helical path. The same milling machine we have used, but here some changes we have done. First changes is that the helical should be done at a particular angle. That's why we have rotated this particular transverse slide or transverse bed with a particular angle, that is 18 degree we have rotated it. And also during helical milling, you can understand that there should be one straight feed as well as rotating feed, so both at a time. So for that, this gearing arrangement, this is the indexing head, and with that gearing arrangement has been done. And as we have told that this is a gear of 117 and it is a gear of 40 teeth, and between them some idle gear has been fixed, so that we can can achieve the rotational whatever our required that rotational operation, as well as straight feed will be given through this particular motion. So combination of both of the straight and the rotating feed and also swiveling the machine or swiveling the bed, we can get that our helical slotting with that particular angle. Now we will see the operation. So now you can see the helical thread or helical slot has been prepared. It is not a thread, it is a slot. So helical slot has been prepared by using the indexing method and also the cutting it in a groove, helical groove. Now we will see the next operation. Okay students, now next operation, that is the gear cutting operation. As we have discussed that this gear has the 44 teeth and we want to cut these different teeth on the gear, and this is the indexing plate. So in that indexing plate is, as you can see that there are many holes. So there is a particular number of holes on each side or each periphery. So outer periphery it will have 41 number of holes, then after that there are 39 numbers of holes, then 37, then 33, then 31. So there are different number of holes are there at different periphery. So while we are doing indexing, as we have seen that plane indexing, the formula is 40 by n. So here 40 by 44, as a 44 is a number of teeth, which is giving you as a 10 by 11, which is 30 by 33. So if we will go to a 33 number of hole, that is the second hole, this particular radius have total 33 holes. So if we will go indexing with this particular radius holes, so here we have to cover 30 holes among the 33 holes. So that's why this particular attachment has been put here, so that while we are doing particular this thing, and after that we are just rotating it by a round and we are fixing it to next set. That means it has been rotated by its total pitch amount, or total how much it should traverse from one head to another head. So this is called as a indexing method. Through this indexing method we can specify or we can make uniform space between the teeth, and this indexing method is required for the milling operation while we are cutting the particularly your teeth. And one more thing to be mentioned, this particular job has hole inside. So for holding this particular type of job we are using mandrel, and here in this attachment, as you can see here, with this attachment with the mandrel we had hold this particular job over there with this mandrel. So mandrel is nothing but a particular shaft through which we can use, or this particular job can be fixed over the system or over the main bar, and the other system is remains same, that is primary cutting motion will be giving through this particular main mandrel or main the R bar, and this is the to giving the feed motion. Now we will see the gear cutting operation. Okay, so first gear or first teeth has been cut. Then for next one we will now do the indexing. Now you see in that hole we should have to move by 30 amount of hole. So now 30 amount of hole on that 33 number of plate has been moved. So now we will do with that particular amount of hole, again we will cut the gear. So you can see now that one teeth has been cut. Similarly, the other teeth also can be cut by same way, by doing this indexing method repeatedly, so that we can get hold of number of teeth and equal spacing with different periphery at the periphery. So we will see the next operation now. Okay students, now we will see the next kind of operation, which is the slotting operation. So slot is basically finding the keyway or forming the keyway. You can see the slots here. These are the different keyways which usually can be made on this particular board. These slots will be helpful for power transmission case also. So this slotting has been done through this machine, slotting machine. So this is the simple operation. This particular workpiece has been held by through this mandrel on this particular work bench or on the particular your face or the bed, we can see here, and the cutting operation has been given through this particular cutting tool. You can see here cutting tool has been mounted on the slotting machine, so that it will reciprocate, the arm will reciprocate and the cutting operation can be done with this particular workpiece. So while the arm is coming down, means downstroke operation, the main cutting operation, the primary cutting operation is taking place, and while it is the kind of a upstroke, that is kind of a ideal operation. So with this particular operation, the keyway is being formed, and with this operation we can and after that one keyway formed, we can rotate it particularly by the 90 degree, and we can cut another keyway whatever we want as per our design requirement. Now we will see the cutting operation through this slotting machine as per demonstration. So you can see now that that is the primary cutting motion which is giving to on the tool, and it is cutting the workpiece, and we are giving the depth of cut through this particular attachment or rotating that particular attachment, and that depth of cut we are giving as a 3 mm depth of cut in total. So you can see the material is removing particularly in downstroke, and upstroke is a kind of a ideal stroke. So now you can see the slot which has been created due to downstroke movement of the tool, and like this way now if we can rotate the workpiece, it can be cut at any angle whatever we are desired for. So this is the slotting operation which can be used for making keyways. Now we will see the next operation. Okay students, so next operation we will see the shaping operation. Shaping operation, basically if you have this bar, you want to shape it, means if there is any undulation on the surfaces, so we want to shape it or we want to put it as a fine finish. So this is the shaping machine which we are going to use for the shaping of the mechanism or for the shaping operation. So cutting tool is connected with this here, you can see here with the tool holder, the cutting tool has been connected over there. So it will be connected, or then this particular ram can be slided, means it can be come forward, come backward. So like this reciprocating motion has been given to this particular tool, and the this table can be fed or can be cross-laid through this particular handle. It can be table can be moved this side, and the depth of cut we are giving, or the cutting main action of the depth of cut we are giving through this particular this rotating handle, so that the whatever the amount of the chip that can be removed or that can be required to remove in a particular single pass, that can be calculated and given through this particular depth of cut. And so you can see here this particular forward cut is the main cut of the machine removal or the removal process. So the backward is kind of a idle thrust or the idle movement. So here in this process we are using some quick return mechanism, so that it can return quickly to its original position and it can start cutting with the next slide or the next cut. So with this particular operation we can use, we can increase the depth of cut by step, and we can form this particular surface with a very smooth surface finish we can achieve. And on the particular width of this job, there will be certain width. So for covering that width, we are particularly sliding this workpiece in this particular horizontal direction, so that this total way or the total width can be cut through this particular machine. So now we will see the shaping operation, and through which it can be operated and the surface can be generated. So now you see the depth of cut is being given through the top feed. Now the shaping operation has been started, the scratching on the workpiece. So forward stroke is the main chip removal mechanism. At the forward stroke it can be seen, and backward stroke is kind of a idle stroke. So after each stroke complete, so this is a starting forward and backward, then forward and backward. So after each stroke complete, the machine or the table has been moved a particular small amount, so that the next set of the machine or next set of the surface can be cut. So now you can see that new surface has been revealed. So it is through the shaping operation, the new surface has been revealed, and like that way we can do shaping or any kind of slot if you want to cut, that can be also can be done with this shaping machine using this particular V tool. So this is the process, this is the another useful process through which the machining can be done. So this shaping process is one of the useful process, and it can be done with the single point cutting tool. Thank you.